Hi guys, in this video we're going to have a look at exponential graphs. So an exponential graph, you might have heard the word exponential potentially in biology, I think, when you talk about the reproduction of cells or bacteria or something like that, or exponential growth. And it's exactly the same meaning in maths, and hopefully when we plot a few of these it'll make a bit more sense as to what it actually means. Okay, so an exponential graph would be something like this, where we have a number. So in this case I've just represented that by a, and it's to the power of x. So that's the crucial bit, it's to the power of x. That's what makes it an exponential. Okay, so I've got three examples here. I'm going to plot this one and then just fill the tables in for these ones. Okay, let's get cracking. So again, if you don't have a table given to you and you're asked to plot it, I highly recommend you just plot a very quick table here. So I've got my x and y, just like I've done with straight lines, quadratics and cubics, and I've gone from -3 to 3 for my x values because that's what's on the graph. Okay, and all I'm going to do is substitute these values for x into that equation there. Now I'm going to start off with 0 and do the positives just because they're a bit easier. So 2 to the power of 0. Now hopefully you remember that anything to the power of 0, this is from your indices work, anything to the power of 0 is always 1. Okay, and then we've got 2 to the power of 1 because 1 gets substituted for x, so 2 to the power of 1 is just 2. And then I'll substitute 2 in for x, that's 2 squared, so 2 squared is 4. And then I'll substitute 3 in for x, so that gives me 2 cubed, which is 8. Okay, and then we have 2 to the power of -1. Now, when you do 2 to the power of -1, I'm just going to come over here to illustrate this. So this is again your indices work. So anything to the power of a negative means you flip it. Now, if you see in my video, what I do is I go, okay, what's 2 as a fraction? Well, that's 2 over 1. And then because it's a minus, as I said, you flip it, so it becomes 1 over 2 to the power of 1. And because it's to the power of 1, we just do 1 to the power of 1 and 2 to the power of 1, which leaves us just with a half. So that's a half. And exactly the same thing for here. Treat it as 2 over 1 to the power of -2. You flip it, so then it'd be to the power of 2. 1 squared is 1, and 2 squared is 4, so that will be a quarter. And the same thing with -3. Treat it as a fraction. Because it's a minus, flip it, so it becomes a half to the power of 3. 1 cubed is 1, 2 cubed is 8. So it's 1/8. You might just recognise the pattern here. Look, when x is 1, you get 2. When x is -1, it's half. You just flip each of these into fractions. Okay, so let's now plot that. So we've got, when x is -3, we have 1/8. In fact, I'm going to go backwards to make it a bit easier. So when x is 0, we have 1. And then when it's -1, it's a half. So I need to go halfway through that square there, then a quarter, so then halfway again, and 8, so halfway again. Okay, so it's something like that. And then we obviously have 1, 2, 2, and then y is 4, x is 3, and y is 8. And again, just like I've shown you before when plotting, turn it around. So when you draw your curve, it needs to go through each point, but it naturally goes with the curvature of your wrist. If you try and do it like this, it's not a natural flow. So try and turn your paper around and try and get a nice natural flow. Do it in pencil in case you make a mistake, like you don't go through a particular point or something like that, because you will lose marks. I'm going to do it in pen and hope for the best, purely because if I use pencil, you're not going to be able to see it very well. Okay, so there we go, through that point. I'm now starting to get a bit uncomfortable, so I'm going to turn it round to make that bit just a bit easier, like that. Okay, so all exponential just means is you start off really small, and then as you move along you get bigger, and then it increases with size as it goes on, so it gets bigger, and keeps going, and there's a really steep line going on up here, and that's all exponential means. Okay, something like that, and that's what it always looks like, and it will always go through the y-axis at 1, because anything to the power of 0 is 1. There is one exception to that, which I'll talk about later, but all of these bonds here, okay, will always go through the y-axis at 1. So let's just fill these tables in then. I start off with 0 again, so 3 to the power of 0, as we've already just mentioned, is 1. 3 to the power of 1 is just 3. 3 to the power of 2, so 3 squared is 9, and then 3 to the power of 3 is 27. And again, we've got our same thing here. Treat that as a fraction, so 3 over 1. Because it's a negative, flip it, so it becomes a third to the power of 1, so it just stays as a third. Same thing with here. Treat it as 3 over 1, so minus. Flip it, so it's a third. Square it. 1 squared is 1. 3 squared is 9, so it's just 1/9. And again, it follows the same pattern we did here. So this one here, I'm just going to flip that to be 1/27. And if you plot that, it looks something like this. So again, it starts off pretty small, crosses the y-axis at 1, and then it gets really big. So that's just your exponential again. And last example here, just to have a look. Again, 6 to the power of 0 is 1. 6 to the power of 1 is 6. 6 to the power of 2 is 36. And 6 cubed, I think, was 216. I'll just get the calculator and check, just in case I'm telling you porcupines. Yep, 216. And just like we did here, just go backwards and flip it. So it'll be 1/6, 1/36, and 1 over 216. And if you plot that one, again, it looks the same sort of thing. So really, really small. Comes here, crosses the y-axis at 1, and then goes really big. So that's what an exponential graph looks like. Okay, so I did say there's one exception when going through the y-axis at 1, so let's have a look at that. Okay, so if you have something like this, where this bit is the exponential, but you take away 3. So if you do x is 0 over here, as we saw in our first example, that would cross the y-axis at 1, but then you minus 3. Okay, so it's just, if you have something going on after the exponential, then it won't always cross the y-axis at 1. So let's fill this table in and plot it to see what it looks like. Okay, so if I treat that the same as the first example, so 2 to the power of 0 is 1, take away 3, I have minus 2. 2 to the power of 1 is 2, take away 3 is minus 1. 2 to the power of 2 is 4, take away 3, these move 1. And 2 to the power of 3 is 8, take away 3 is 5. So basically it's exactly the same as the first example, except I'm just taking away 3 on both of these. Sorry, on all of them. So 2 to the power of minus 1, that was a half. And then if I take away 3, that's going to give me minus 2.5. And then if I had 2 to the power of minus 2, that was a quarter. Take away 3, that's going to give me minus 2 3/4. And then 2 to the power of minus 3 we said was 1/8. Take away 3, that's going to give me minus 2 7/8. So I'm just using that first example to help me, and all I'm doing is just taking away 3 each time. Okay. And then we can plot. So again, I'm just going to start off with 0 and then minus 2. So as you can see, it doesn't cross the y-axis at 1 here because I need to minus the 3. So 1, 2, 3 there. And then minus 1 was minus 2.5, so it's halfway between that circle, that square, and then halfway again, because it's 3/4, and then 1/8 there. And when x was 1, we had minus 1. When x was 2, we had 1, and then 3, we had 5. So it's exactly the same looking exponential graph as the first example, except every single point has just been moved down 3. And if you've looked at graph transformations, you'll know that that's all that means you do. When it's minus 3, all the points just move down 3. Okay, that's the one case where it doesn't always cross the y-axis at 1. Again, I'm going to rotate round and use the natural wrist movement here to go through these. Again, use a pencil. Don't be that person who thinks I'm too good, I won't make a mistake in the exam. You make a mistake and you lose easy marks. Okay, so that's that one. And the final thing to have a look at is what happens when you have something like this. So when the number is less than 1, in other words, if it's a fraction or a decimal, what happens? Okay, so let's have a look. Well, as always, a half to the power of 0, like so, will give us 1. And 1/2 to the power of 1 will just give us a half, so that's fine. 1/2 squared, well, 1 squared is 1, 2 squared is 4, so it's a quarter. And 1/2 to the power of 3, so 1 to the power of 3 is 1, and 2 to the power of 3 is 8, so we have 1/8. Okay, and we have the negatives here, so I'll do a quick example of that to illustrate my point. So if I have 1/2, I'll tell you what, let's do the -3 because it's a bit more interesting. So the power of -3. As I said before, if it's the power of a minus, we flip it, so it becomes 2/1, and you still have to the power of 3, so just dealt with a minus by flipping it. This is all the indices stuff. 2/1 is just 2, so I can just simplify that to be 2 cubed, which gives me 8. So you might already notice it's just basically the other way around. So that's going to be 4, and that's going to be 2. And when we plot it, so -3 is 8, is there. -2 is the 4, which is there. -1 is the 2. The 0 is the 1. And then we go halfway, half it again, and we halve it again. And again, I'm just going to rotate round and try and get a nice smooth curve going through these points here, like so. Okay, so just a quick thing there. If it's a number more than 1 or more, it's just like that. It starts off small and goes increasing. However, if it's a fraction or a decimal, something like this, it's just the other way around. So it starts off really big and then gets really small. So just a little bit of a heads up about what that might look like. So yeah, that's exponential graphs, guys, and how we draw them. Hopefully that helps. Thanks for watching.